Okay, in this video we are going to start section 2.3, and that's covering linear functions and slope. And we'll get through these first three objectives in this video. We'll calculate the slope of a line, write the point slope form of the equation of a line, and write and graph the slope intercept form for the equation of a line. Each of these you have seen before in probably Algebra 1 and Algebra 2, so nothing too drastically new here. In this graph, we have across the x-axis the percentage of adult females who are literate, and on the y-axis the under 5-year-old mortality rate per 1,000 people. And it looks like the graph has a lot of dots scattered across it, and it looks like we have a general downward trend here. So it says data presented in a visual form as a set of points can be called a scatter plot. As shown in the figure above here, we have a line that passes through or near those points. A line that best fits the data points in a scatter plot is called a regression line, or some books you might have seen that referred to as a line of best fit. By writing the equation of this line, we can obtain a model for the data and make predictions about child mortality based on the percentage of literate adult females in that given country. Data often fall on or near a line. In this section, we're going to use functions to model such data and use that model to make predictions. We begin with a discussion of a line's steepness. And mathematicians have developed a useful measure for the steepness of a line, and we call that slope. Slope compares the vertical change, or the rise, to the horizontal change, or the run, when moving from one fixed point to another along that line. To calculate the slope of a line, we use a ratio that compares the change in y, the rise, to the corresponding change in x, the run. Of course, to find the slope of a line, we need 2 points, so we're going to call this point 1, x1, y1, and this point 2, x sub 2, y sub 2. So to find that change in y, or the rise, and the change in x, the run, we subtract those coordinates. Notice we use one point here, x sub 2, y sub 2, and we subtract the other point here. Don't get those points backwards in just the numerator or the denominator, or we'll get the wrong slope. Graphically, here's our first point, x1, y1. Here's our second point, x2, y2. And we're finding the rise, or how much we have changed along the y-axis here, with the run, or how far we have moved along the x-axis down here. And of course, we'll have to make a little distinction here. x2 minus x1 cannot equal 0, because of course we don't want 0 in our denominator. If the x coordinates are the same, that would mean our 2 points lie above and below each other, and we would have a vertical line with undefined slope. But more on that later. So we're going to find the slope passing through these pairs of points. Okay, I highly encourage you to draw these arrows when we figure out our direction in which way we're going to be subtracting these, because let me write it up here. We'll have, our numerator is the change in y, or y2 minus y1, over the change in x, x2 minus x1. Should we call this point x1 or this point x1? Actually, it doesn't matter as long as you apply them consistently. For this first example, we'll do it in both ways to show that the slope doesn't matter, or the order which point you pick does not matter. So here, I'm going to start with my y coordinates, and let's subtract left to right. So I'm going to go in this direction, -1 minus 4 in the numerator, and then I'll keep that same direction here, -3 minus -2. And if we subtract those here, we're going to add the opposite, and our numerator is now -5. And in the denominator, add the opposite. -3 plus 2 is -1. And then those two negatives will cancel out to be a positive 5 over 1, or just 5. Now let's say on the flip side, somebody else wanted to use those points in the reverse direction. So maybe they subtracted right to left. So 4 minus -1 in the numerator. And then the denominator would be -2 minus -3. So here again, add the opposite. That turns into a positive 5. -2 minus a -3 turns into 1. So here we had a negative divided by a negative. Now it's positive divided by positive. End result is the same. Those slopes are the same at both 5 over 1. Now, the only real mistake you can make here when finding the slope of a line is to maybe you'd subtract your y coordinates right to left, and then your x coordinates left to right. That right there is the big no-no when finding the slope of a line given 2 points. All right, letter B. Let's see here. I'll subtract left to right. What the heck? 4 minus negative 2 in our numerator. Denominator, negative 3 minus 2. So here we're going to add the opposite and get a 6 in the numerator. Negative 3 minus negative 2, that'll turn into a minus 5. And that was in our denominator. That negative was in with the 5. If we had subtracted in the other order, that negative would have been in the numerator with the 6. Either way, end result is the same, negative 6/5. And I guess we could take a look at here. Here's the graph. Here's the 2 points. Negative 3, 4 is up here. Negative 2, negative 2 down in quadrant 4. And we can see the slope of the line. We went down 6 units and then over 5 for our rise and our run. And I guess we can look at the graph for the first set of points. Negative 3, negative 1 down here in quadrant 3, negative 2, comma 4 here in quad 2, and the slope of that line was 5, if I remember correctly. Yeah, 5 over 1. So from the point on the left, we'd go up 5 units and then run over 1 to get to that second point. All right, just the general idea of slope here. If the line is rising from left to right, that would be positive slope. I'm going to abbreviate POS. And then if we are going downhill from left to right, that would be negative slope. If the line is horizontal, that is 0 slope. Because we don't rise any, it's all run. No rise, all run. And if the line is vertical, that would be undefined slope. Abbreviate undefined there. That's all rise, no run. And that's like dividing by 0, because if we pick any 2 points on that line, they're going to have the same x-coordinate. When we subtract them in the denominator, we will have a divide by 0 scenario. Like say that was 5 over 0, we would rise 5 and then run 0. So you just go straight up and put another dot there. All right, in the box we have the point slope form of the equation of a line. This is a pretty useful equation. They call it point slope because we do have a point, that is the x sub 1 and the y sub 1, and we do have a slope. Slope is represented by the letter m. So there's our point, and our slope is the m. Now, since it's a video and you can't ask me a question, it looks like we have a great question down here. When using this equation, for which variables do I substitute the numbers in? When you write the point slope equation of a line, you will never substitute numbers in for the x and y. So this y and this x without the subscript numbers, those stay variables. You plug in numbers for the y sub 1 and the x sub 1. All right, example 2. Write the equation for a line in point slope form. Write the equation in point slope form for the line with a slope of 4 that passes through the point negative 1, 3. There's our key stuff in this problem. The slope is 4 and our point is negative 1, 3. And then it does say, then solve for the equation for y. So our point slope is y minus y sub 1 equals slope m, quantity x minus x sub 1. So the slope, that m becomes a 4. And then we're going to have our x minus something, and over on this side, y minus something. And our x that we're going to subtract is negative 1, and our y value is positive 3. To make this look prettier in point slope form, I'm going to leave the y minus 3 over here. And in the parentheses here, x minus a negative, we'll turn that into add the opposite. That'll become an x plus 1. So here is our equation in point slope form. Now the second part here says solve the equation for y. So we want to do two things. We're going to distribute this 4, and then we're going to add 3 to both sides. So this is going to be 4x plus 4, and over here is y minus 3. And then we're going to add 3 to both sides. So y equals 4x plus. This 4 plus the 3 is 7. So there's our equation solved for y, and of course this is slope-intercept. All right, example 3, write the equation in point slope form for a line passing through these 2 points, and then solve the equation for y. Now the difference between example 2 and 3 here, example 2 they handed us the slope on a silver platter. They said the slope is 4 and gave it right to us. In this problem, example 3, they did not do that. But can we find the slope since they gave us 2 points? Well, you betcha. So step 1, find slope. And then this will be just like example 1. We got 2 points. Let's subtract them and find the slope between them. So I'm going to subtract right to left. I'm going to have a 6 minus a negative 3 in the numerator. And then my denominator, x minus x, will be a negative 2 minus 4. So let's see here, 6 minus a negative turns into a plus. Our numerator is a 9. And then our denominator, we would add those two negatives and get a minus 6. And both numbers are divisible by 3. So that'll become a negative 3 halves. M equals negative 3 halves. All right, now we have a slope. And again, in example 2, we had the slope and they gave us 1 point. Now we found our own slope and we have 2 points. So which point should we use? Will one of them give us the right answer and the other give us the wrong answer? Absolutely not. Just for the sake of argument, we're going to do this with both points and see that they do come out the same. I'll call this the red point here, and we'll plug that into point slope. Y minus the negative 3 equals the slope negative 3 halves times the quantity x minus 4. And I'll do a little divider line here. And then I'll call this the blue point, and I'll use the same slope and plug the blue point into the same point slope equation. Y minus 6 equals the same slope, negative 3 halves, times quantity x minus negative 2. So when we clean both of these up, well, this would be, we wrote the equation in point slope form, so that's the first part there. And I guess we could say add the opposite, and add the opposite here. Now if we solve both of these for y, we should get the exact same thing. So the first thing on the right here, I'm going to distribute the negative 3 halves. That'll be negative 3 halves x. And now we have negative 3 over 2 times negative 4 over 1. Well, the negatives will multiply to a positive. And then we have 12 over 2, which divides out to a 6. And last step, subtract 3 from each side. Now it is negative 3 halves x. Oops, forgot my x, plus 3. So let's see if we get the same answer here on the other side with the blue point. Again, first step, so distribute the negative 3 halves slope. So now we have negative times positive, which is negative. 3 over 2 times 2 over 1 is 6 over 2, or that is a minus 3. And now to finish off the problem, I'm going to add 6 to both sides. And I get y equals minus 3 halves x. Negative 3 plus 6 is positive 3. And yes, they are exactly the same. Doesn't matter which point you use. You know, I usually look for one that might have a 0 in it or very low numbers like 1s and 2s. Much easier to do the arithmetic involved with a problem like that. And then here's our graph. You know, here's our 2 points. 4, negative 3 is in quadrant 4. Negative 2, 6 is up in quadrant 2. And when we connect those points, we can do a little check here and see, since we're in slope-intercept form, our y-intercept should be 3. And as a matter of fact, it is. And our slope is negative 3 halves. We can go down 3 over 2. We hit that point. Down 3 over 2 more. We hit the x-intercept. Looks good. Alrighty. Some practice problems for you to try. You know, pause the video and then fire it back up and see if your answers match mine. All right, for the first one, I see a positive y value here and a negative, so that's going to, I'll like to subtract in that order. 4 minus a negative 2 is our numerator. Negative 3 minus a negative 4 is our denominator. We add the opposite on both of these, and we get 6 over 1. And then for letter B, again, I'm going to subtract right to left. 5 minus a negative 2 over negative 1 minus 4. So here, add the opposite, we get a 7. And then we add the opposite with the denominator, and we get a negative 5. So 7 over negative 5. If you, again, subtracted them in the other order, you'd get negative 7 over a positive 5. Again, the end result is the same. Oops. Again, here are these two types of problems, like I did point out in the examples. Oops. In number 2, we're given the point and they hand us the slope right there at 6. And then at checkpoint 3, they just give us 2 points. So we will find the slope and then use one of those points to find the equation of the line. Okay, so here we have our slope is 6, m equals 6, and our point is 2, -5, which is, of course, our x sub 1, y sub 1. And we throw them into the point-slope equation. Y minus a -5 is equal to slope 6 times the quantity x minus 2. And this will turn into a plus. Y plus 5 equals, distribute the 6, 6x minus 12, subtract 5 from each side. Minus 12 minus 5 more takes us to -17. So here's our point-slope equation, which they asked us for at the start of the problem. Write the equation in point-slope form. And then we solve for y, and here we have y equals our 6x minus 17. Okay, this problem is basically the same thing, but with a little more work. First, we have to find the slope. And this time I'll go left to right. What the heck? Minus 1 minus a -6 divided by -2 minus a -1. And -1 plus 6 takes us to 5. -2 plus 1 is -1. So there's our slope, -5. And then now we got to use that slope in one of these points. I lean toward the ones with the smaller numbers. Here I see a -6, so I'll lean toward this point. -2, -1 is the point I'm going to use. So y minus a -1 equals slope -5, x minus a -2. So on the left now is a y plus 1. We distribute the -5. And now we want to subtract 1 from each side. Y equals minus 5x. -10 y minus 1 more takes us to -11. Alrighty, I hope your answers matched mine. And I hope mine were right. Here's some homework problems to give you a little fun tonight. See you in the next video.